Hello everyone! It's been a while, so I figured I could give an update on what I've been messing around with lately. My main project has been a new revision of the palette to external filament buffer. I've implemented some new features and done some small optimizations and improvements to it. And that has taken a lot longer than it should have, mainly because I decided to switch CAD tool. So there was a bit of a learning curve for me. What you see here is the previous version, the one that is on Thingiverse right now, and that you have seen in some of my other videos. And it is working okay, but it is fairly hard to load. When I'm starting a print with this, I usually just let the palette feed filament in here, and I just route it around these wheels and let it go straight out, and let it just run till the palette has done making the initial filament. So then I have a lot hanging out in the Teflon tube sticking out here. When it's done, because it's only going straight through and not falling like swiveling around the wheels like it's supposed to. So then I clamp this filament to this wall and take it out and manually just wrap it around, bending out the walls enough that I can snap the filament in between there and route it around there and come here and do the same here, just bend out the wall and snap it in. So that works okay, but it's a bit annoying. So I've implemented a new method of loading it in the new version. So can go look at that here. Here's the new version. So like I said, I also switched from Onshape, which is was what I designed the previous one in, to Fusion 360. The reason for that is mostly because of the license change that I did some time back in Onshape. So it's it's about twice the price, I think, of Fusion 360, and both of them have a free license. But with Onshape, if I make a single dollar of this, then I have to purchase the full version, which is very, very expensive for Onshape. And yeah, since I actually have gotten some donation on Thingiverse already on this, so I have to either buy the full license to stay legal, or I will have to switch to Fusion 360. They have this startup license, which is, or maker license. It's their free version. The main difference is that they allow me to earn, is it like, I think it's $100,000 per year before I have to go purchase a full license. So that's really nice, because I mean, if you're making that kind of money on your CAD software, then sure, you should go pay for it, buy it. But I'm not making any money from it right now, so I can't afford, because this when you're gonna buy the full version of Fusion 360, it's a considerable amount of money, but they're very generous with how much money you can make from it before you actually have to go purchase the full version. So I have actually tried to switch a couple of times before. I think actually when I started the original version of the palette buffer, I started it in Fusion 360, but there was a couple of concepts that I didn't get, so I found it very frustrating, because I was so used to Onshape and things didn't work the way I wanted them to work in Fusion 360. And like that project and a couple of other projects, I started at 360, got frustrated, things was moving too slow, and I eventually said screw this and popped right back into Onshape. So, but like around the time where I actually released this buffer on Thingiverse, there was a user redemption 1 on the Mosaic palette to user forums that linked me to some tutorials by, let's see, I think I have that web page here. Like this guy, Lars Christensen. He have some beginner tutorials for Fusion 360, which is really good, and it made like a couple of concepts that hadn't clicked for me. They clicked when I watched the beginner series here, and suddenly it all made a lot more sense. So my main problem was that in the beginning I I didn't understand fully how the edit history was recorded, so I had problems going back, changing some of the parameters of features that I had done some time back. There's still I still find it a bit quirky, and it's very easy to screw up in Fusion 360 by editing features from a component that you haven't remembered to activate, and then the history is recorded on the wrong object, the wrong component. And it's if you make that mistake, it's very hard to go back and fix it. So I have to be careful. So in the beginning, I made that mistake a lot because I wasn't used to that workflow from Onshape. But now it's going much better. I have gotten a routine to that, so I usually don't forget to switch. So yeah, I'm getting more and more happy with Fusion 360, and I'm really happy with the license, and it have a few features that I know would miss a lot if I went back to Onshape. So far I'm very happy with the switch, but of course it took me a lot longer to do the upgrade of the palette buffer because I basically made it again from scratch in Fusion 360. Of course I had all my measurements and stuff, and I knew how I did it last time, so I got up to speed a lot faster on the design of the buffer, but I had to do it all from scratch. I could have exported it from Onshape and then imported it here, but then I would end up with just each component would be a solid with no parametric history at all. So doing like small tweaks to the design would be impossible. So and it was a very good project for me to learn on, because I knew very well, like the beginning of the project, I knew exactly what I was going to do because I was basically just replicated what I've done before, and I learned Fusion 360 along the way. Now I feel pretty comfortable in it. So, but yeah, this is the new version of the buffer. You can immediately see a couple of changes. Like the other one was like a square box here with what did I do now? With yeah, I'll just undo that. I don't know. That's a bit scary. Like this thing. You can, like, if you right click, of course that's my main problem. I use so many tools at my job. I use various tools where you're using, like, you're panning around and navigating with the mouse, and I use Onshape and Fusion 360 and other tools that allow me to navigate with the mouse like in similar fashion, but they all have different ways to do it, and it messes up my brain. So like some of them use right click and drag to pan, and when you do that here, you actually get this menu, and then if you want to go up here, you see I can now select part of this menu. So you quickly drag up there and release there, and okay, now I deleted something. So switching forth and back between different 3D programs and other programs that use this kind of navigation is very frustrating. But and of course none of them allow you to properly configure it, so you could configure them all to work the same. So you have to context switch every time, and that is very frustrating. But okay, enough ranting about that. Here you can see I've removed that corner. The very first version of the buffer was a square box, but all this area here was not used at all, so I just cut that away in the previous version, and in this version I also cut away the corner here. That of course has some implication, because the spring that keeps the tension on the buffer was actually going out here. If we switch back, as you can see here, you have this rail there where you can put a screw in wherever you want based on what tension you need. And there's a spring which is drawn in here, but it is mounted there, and that is going into a spring spool here that will cause this spindle to turn anti-clockwise. On this one, I decided to, instead of having it go straight out there, oh no, I did it again, because now I've just been using Onshape again for a few minutes to set up so I could show you the previous version, and my brain is already a mess. Okay, so this is how I do it here. So you see here, now you can see the spring spool in there, and now the spring will go into the area under here instead. So I have an opening in the back which wasn't there on the previous one. So that's one optimization, so I can make it a little bit smaller, save some material and some printing time, and also some space, although that it's hard to utilize that space for anything, but I also think it looks cooler. Another thing that has changed is the inlet tube. We could go back to the other one again, which looks like this. You see here the whole corner has this adapter for the inlet tube. My main reason for making this a separate part is that I expected this to break every now and then. It's a pretty thin walled tube of a very brittle material that is being handled quite roughly as you attach it and detach it from the pallet. So I figured this is probably gonna break every now and then I didn't want it to be part of the enclosure because that takes a lot of time to print. So it's much easier to just print this small adapter and then you have it fixed. Another thing was with this one, I could actually make one adapter with the inlet here, because in the earlier versions of the buffer, you had inlet just like the outlet here. So it had a Teflon tube, or like a Bowden tube, going from here to the pallet, and then another Bowden tube going from here to the printer. So with this setup, I could just make a new adapter if I wanted to go back to that system. So, but by now I've kind of made up my mind on that. I don't think I will go back, so I will have to just design a new enclosure. But I decided to simplify this whole thing quite a bit on the new version. So here, it's just a small slot there, and you have a tiny adapter in there. This is really quick to print, like so, right? So if you break it, you can easily print one of these. It even prints without support, so that's one of the annoying thing I've had with the buffer, because like I've had few occasions where it has exploded because of the bug in the pallet 2 that caused it to like randomly decide to stop feeding filament. And of course, what happens then is that you pull all the filament out of this, so you fully wind. Yeah, here I can actually just drag this around. Right, so you turn this wheel over here until you have the filament going as a guitar string through here, getting more and more tension until eventually it snaps. And then the recoil, as this one flies back and then hit the stop, is putting enough G-forces on this thing that at one point I broke the wheel off the like the pole that the bearing is mounted to the enclosure on. Broke off. In another case, it broke the end stop. And I also have it throw one of the wheels. So there is a lot of force going on when when it's at full tension and then releases, because it accelerates to a very high speed and then it hit a very hard stop. And when that happened, it's been super annoying because now my palette is of course calibrated to work with this buffer install. So I can't just go back quickly and print something multi-material without the buffer. And most of this buffer require a lot of supports to print. And then I want to use the palette so that I can use soluble support. So when that happened, it's like, okay, I'm now stuck with the broken buffer and I can't print the spare parts because I can't use the palette anymore. So I always manage to work around it by either one way is of course to recalibrate the palette to work without the buffer and just print slower. But I've usually gotten around with normal supports and get uglier parts. But that is something that has worked well enough that I can print some real parts again. So. But that's something to consider. I'm now printing spare parts for this. Like everything on the spindle, you should have 2 of, because it will explode. I'm also actually thinking about I should have some kind of damping on it, so that if you let go, it will like slowly swoosh back and not violently smack back and hit the end stop. So, but it needs to do that without adding any friction when it's moving slow, because I don't want to make more tension on the filament than necessary. So that's something I need to think about. I've been thinking about some kind of like a propeller that's geared up a lot, so that it doesn't cause any friction when it's moving slow. But if you're trying to move it fast, the air resistant on the propeller or the whatever I make, that something that's spinning at a higher rate than this, and either air or oil or something will make it not have any impact at slow speed, but keep it from accelerating up to ludicrous speeds. But that will be for the next version, not for this one. I have now this part. If we try to hide it, you see in here, yeah, I have the inlet here with the chamfer, so that even if the alignment with the inlet adapter here isn't totally perfect, it will just hit this slanted wall and be guided into the hole there, which is still 3 millimeter in diameter, so it have some slack before it's constricting the 1.75 millimeter filament there. And then it's the screw holes to mount it in. Another change is this mounting bracket. The previous version I just used Velcro to mount it on top of the pallet, and it worked kind of okay, but the Velcro, at least the one that I had and that I used, wasn't keeping it very steady, so it would like flop around a bit. And when I was going to actually remove it, it was almost impossible, because Velcro is easy to pull off if you like start in the corner and then tear it off, but if you have to pull it straight up like you have to here, because this tube prevents you from tilting it in any direction, then you will break this. So we had to pull it straight up, and the Velcro is very strong in that direction, so that was a big hassle. So now I'm trying something new. Haven't tested this yet, so it will be interesting to see if it works at all and how well it works. But you can see this bracket here. I haven't set up any animatable joint there, so I will just go and hide it for now. So you see we have this slot here, and the arcs you see here are sections of circles that have their center point in the center of this outlet tube. So the idea is that I should be able to like turn it out a bit, push this down into the pallet, and then just swing it in until the bracket like slides in here. So then it should be very quick to just twist it a bit and pull it up to take it off, and then pull it down and twist it a bit again to put it back on. So I hope that will make it much easier to take it on and off. And then of course to mount the bracket, I'll just put double-sided tape on it and slide it in there where it's supposed to be. Then I will make this enter the outlet of the pallet and just snap it in place where I want it to go, and then the glue will keep this sticking to the pallet, and I can just twist the buffer to take it off. So that I hope will be a nice improvement. Then the design of the wheels has changed a bit. These are now, instead of on the previous version, it was a solid wheel with a lid on the top to retain the bearing. I've changed this now. There is no lid anymore, and the wheel is actually split in two. Let me see, I should be able to just hide this. So you see it's split right in the middle of the groove there where the filament is going, and there is like a small plastic ring there that goes into a slot in the other part, and then the bearing is also suspended in the middle of these two, like extending a little bit into one part and a bit more into the other. So you press this together, and then you put in the 3 screws here, and like if I put back the wheel, yeah, then you screw 3 screws in and to hold the wheel halves together over the bearing, and then you're done. So it makes it a bit easier to print it, because you print each half with the outside facing down. So the only thing that needs a bit of support is this recession here, because you have an overhang here. But this groove is not generating an overhang on the, like before it started here, it would go here without any overhang, but that it would have a pretty bad overhang there and a little bit here. So it wasn't a problem. It printed fine without any supports, but at least now there is no overhang at all. So that is one change. And then you can see there is a new thing here, this handle. That's of course gonna make the previous method of loading it that I use not working anymore, because if you're not threading this directly through here until it's done, and then you want to wrap it over here, this is a closed loop, so you can't get it out of there. So that would be no-go. So but what you can do now instead is to grab the handle and you pull it and lift. Why doesn't it lift? It's yeah, okay, wonder if I grab this one. Yeah, you can like lift the whole thing up, and the idea is that you do that and then you turn it 225 degrees till it's like that. Then you do the loading in pretty much the same way as before. You let the pallet fill the filament in here. You probably have to guide it a little bit to make it exit properly there. Then you just let it run till pallet says that it's done. You have to then make sure either just put your finger over the filament here or clamp it. I hope to make some kind of automatic system to like put a brake on the filament, so you can't pull it out of the buffer, or sorry, out of the pallet. But for now you have to just stop it there, and then you will just manually, or why did you do that? Come on, yeah. Then you grab the handle again and you twist it back, and then it will grab the filament and wind it up on the buffer wheels until it is fully loaded. So, and if you prevent this one from pulling any more filament out of the pallet, you will have to, it's forced to pull it back from the Teflon tube here. And when this one is back to the normal position, you should have the right amount, like the previously calibrated amount of filament sticking out of this Teflon tube, and you just stick it into your extruder and you're good to go. So, and the trick here is of course that as soon as you lift this up, it disengages from the spring, and then you can freely turn it around. No, it's not. Let's yeah. So you lift it up and you turn it till it's like there, and then you push it back down again to lock it. And when you're done feeding through, you lift it up to disengage it from the spring, turn it back to this position, and push it down to lock it again. And now the spring will make sure that it is automatically rewinding. So let's have a look at how that actually works. If we go to the spindle, I guess we go to the bodies, and let's start hiding stuff. Like the handle, let's get rid of the wheels, and let's get rid of this filament. Oh yeah, one thing, the filament. Like in Onshape, when I did, this is one thing I really love with Fusion 360 is why can't I turn this anymore? I don't load that because that happens every now and then. It just stops working, like this animation. I was just gonna tell how much I love that feature, and now it doesn't work anymore. Usually if I undo a few steps. Okay, this is bad. Yeah, so now it works again. So why does it do that? What if I okay, then let's try to go hide stuff again. I was gonna hide the two wheels. No, I want to put back the wheels and then try to animate it. Yeah, like in Onshape, the filament would actually animate for a good while. When I go too far, it will just suddenly just snap over and explode. But then this one, it just caches the position of the wheels and doesn't update the sketches and retessellate the filament. So if you only want to know how I can make the filament animate, that would be awesome. Tell me in the comments, because that would be kind of cool if it could animate, but it's not super important. I mean, the filament is only there for illustration. It's nice to have it there, but it's not really necessary. So, okay, now I derailed. What was I talking about? Yeah, let's start hiding stuff here. So we then go there, and then we take away this spindle top plate. And here you see the mechanism that handle the engagement and disengagement from the spring. So the spindle with the wheels attached is bolted through these 6 screw holes to the this ring under here. Let's hide also the filament, the enclosure. Yeah, so you can see here is the mechanism. There's a bearing in there that make this thing attached to the enclosure, and then you have a spring mounted to one of the holes there, and it's being tensioned down here. So during normal operations, when the pallet runs out of buffer space, it will start twisting this, and that will wind the spring onto this spool. Of course, in the beginning, the spring is pretty loose, doesn't make much tension. So then you have this long arm, and as it winds up, you get the smaller and smaller arm until it's here where it have like a very short arm. And so at this stage, when the spring is going out like that, you have a very high tension on the spring, but very short arm that it acts on. While in this position, you have a small tension on the spring, but a long arm to act on. That makes the torque that's needed to twist this wheel fairly constant. So it isn't getting like tighter and tighter and tighter as the spool fills up. So this part is permanently mounted to the enclosure, and this part is permanently mounted to the spindle on top. And as you can see here, you have when this one is pushed down like that, these teeth will engage here. And on the previous version, there was also it's a similar system, but a much smaller diameter, high-pitched spline, so that you could actually decide the resting angle of the spindle with a fairly high resolution. That was because I wasn't entirely sure how I wanted it in the beginning, so I made it in a way that I could configure it when I was building it without printing any new parts. Now I know where I want it, so I made this fixed setup that it has. You can see it will engage in a few slots, but the main idea is that it's going to be used in, this is the normal working configuration, like there, and then you can twist it the 225 degrees. When I hit that, and then it start to engage the spring here, like this, and this is like the loading position. So you can pull it up, then these guys will have room to go in this groove under the knobs here, so it can spin freely. And then when you have it in the location you want it, you just push it. Come on. Why did it get all confused? I'm confused. Okay, yeah, so when you push it back, it locks. And of course, these slants make it so that the spring tension will no, it locked up again, so I can't edit it, but I'll fix it. Yeah, you see this is slanted so that the normal spring tension will try to force this ring downwards, but it will be stopped by the spindle plate on top there. So the tighter you pull it, the more locked it will become. So I hope that will work the way I have designed it to work. I've actually printed some of these parts and tested it, and first version I had way too tight tolerances here, so it was very hard to engage and disengage it, and it was scrubbing everywhere and it didn't work very well. But then I made this, yeah, you see here, it has a bit of slack here now, which isn't a problem, because of course when the spring is tight, it will rest at the position I want it. So it can go a little bit further back, and it makes it very easy to engage and disengage. So hopefully this design will work properly. And this, yeah, I made this stopper wider, so it means it can take more force, and it also makes it stop in like the end positions where like you can twist it further than what would make sense to twist it, like when you can go from the normal resting position until it's vertical, and then it will stop. So I have as much material as possible. Like the stopper in the enclosure is the same size as this, and together they fill up all this as much space as possible without limiting the normal operating range of the spindle. So, and another thing I found out, like when I printed this test version to test it out, I had all these parts and I was gonna screw them together, and like everything here is symmetrical, like these 3 holes and these 6 holes. There's nothing telling in which direction it's supposed to be oriented, and that is important. So I couldn't figure it out. I had to actually go back into my office where I'm sitting now, where I have my computer, because I have like a mechanical workshop and my office where I do the CAD work. And of course I was in the other workshop, so I had to go back in here, look at the drawings and see like how are the holes supposed to align. And I said, screw this, I should be able to just look at the parts and tell how they're supposed to go together. So I made these small grooves here that is all supposed to align up with this part, like this is part of this. So as long as you screw this together so that this align here, and then when you put on the spindle, it should align with this here, like this part. So now it should be much easier to put it together. Small things you figure out when you are actually trying to build it. So that's the spindle system, the inlet tube, and the mounting bracket. Let's go back, just take a little look at the enclosure. I've done some small changes to the inlet, no, the outlet here. Yeah, first of all, I don't have any knob sticking out there because I have enough space going here, so I don't need it to extend out any further. The Teflon tube that's gonna go to the printer just sticks into this slightly tapered hole, so it will stick in there. And if you look from this side, and let's hide the top of the pull wheel, you see it had a system similar to this, but the previous one had too much spacing here, so the filament, if the filament was bent sharply towards here, as it would go in, it would get stuck on this one. I think from what I've been able to test on the current version, it's very hard to get it to stick there, so so it's a bit more robust like that. so it's easier to load it, even if the filament is bent in an unfortunate direction. So you see this follows this fairly tightly, but there is a little bit of gap there, of course, so that it won't actually cause any friction. But it is tight enough that I was actually not able to insert the wheel. Like I started by mounting or building the wheel, screwing the two halves together and trying to put it on here, and I couldn't make it enter. It was too tight. So to put this wheel in place, I actually had to split it apart again, put down the bottom half, push the bearing in, and push the bearing over the axle here, and get this in place. And then I would put the top half of the wheel on and bolt that onto this bottom half, and then screw the cap in here to clamp the bearing to the enclosure. So that works fine, but it's a bit more hassle to take this wheel on and off, because you have to actually split the wheel, but you usually never do that. It's only needed when you're building it, and if you know it up front that you need to mount it this way, then it doesn't cost you any more time. So I think that is acceptable. And yeah, I guess that's about it. I'm considering making a lid for this so that I can just close it up again, but for now I'm just gonna leave it like this. There isn't any real reason to do that. It can just stay open. For next revisions, I'm probably gonna make a similar cutout here, where I'm gonna have one or two switches, that like one that will trigger as soon as you have movement here, so you know that it has started to, like the pallets buffer is depleted and it have started to drain this one, because I can use that in the pallet 2 plugin on the canvas hub to stop it from sending pings when the buffer is not completely full, because if you get pings when the buffer is not full, the calibration gets screwed up. So I'm gonna experiment a bit with that to try to stop sending pings when the buffer is starting to deplete, and hopefully it will be better to have a few missing pings than some pings that give false data. So I'll see how that's gonna work, and I might also have another switch, like when it's starting to get dangerously close to being drained completely, so that I can trigger another event there, then that will either slow down the printer or maybe even pause it completely. Like if it is getting really close to a full run out where the print will fail if it goes any further, it's better to just pause the printer and wait till it starts filling up again and then restart the print. So, but that will not happen in this revision. That will be for the next one. So for now, this is about it. I have already started printing parts of this. When I'm I've ironed out the last few quirks here. Like I'm gonna make the diameter of these holes. I will put all these holes closer to the edge here, because I mean this bearing is going nowhere. I don't need as much tension there as I need along the edge, because if the filament is really tight and it was able to bend up the wheel enough that it would like slide in between the two halves, that would be a massive jam. It would actually be a complete failure, so it's very important that doesn't happen. So I think it's I'm not sure why this is the same diameter as as I had when I had a lid, so I changed the design around it, but I kind of forgot to move the holes out, so it makes much more sense to have them along the edge here, a bit further out at least. So there is a few like small tweaks that I will still do, but in general this is getting very close to be done. I'm gonna make final print of it and do some tests and make a build video where I show how to put it all together, and get the new version uploaded to Thingiverse. So yeah, hope you enjoyed my little tour of the palette buffer. Now we know some of the reasons behind the design and what will come up next. If you liked the video, please give it a thumbs up. If you didn't like it, give it a thumbs down and tell me why in the comments. See you next time, and bye bye!